times x minus c sub I times x minus c sub 2 and dot 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 up until x minus c sub n. And n, as you look through this theorem, is equal to the degree of the polynomial. Now, what does this actually do? We're going to go through a few examples, and two of them actually, and what the problems will do is give you a set of solutions, not necessarily x-intercepts, but that would just be real solutions, but a set of solutions, an inclusion of all the real solutions and all the imaginary solutions. And then from those, ask you to come up with the original polynomial. They'll also have to tell you what point the graph goes through. And the point that the graph goes through is what's going to allow us to figure out what a sub n is. So x, now what are these c sub 1, c sub 2, and c sub 3 stuff, and c sub n? These are your solutions. Those solutions that they give you will be, again, either real solutions, those are x-intercepts, or imaginary or complex solutions, which, well, I just said it, are your imaginary solutions. Before we actually start a problem, though, I want to come up with a really simple example and remind you of how to factor, how to solve by factoring. So we're going to say that x squared plus 7x plus 10 equals 0. And we're going to solve this by factoring. Well, when you solve by factoring, you take the polynomial, in this case a quadratic, and you factor it. Now the first step of factoring, again, is to see if there's anything you can divide out of all the terms. These do not all have x's, and nor do they all have a common divisor. So factors of the first term, we're going to go on the first two blanks, which is x and x. Factors of 10 is going to go in the last two blanks. Now when your leading coefficient is 1, all you have to ask yourself is what factors of 10 add, or if this were minus, subtract, but this is addition. So what factors of 10 add to the middle number of 7? Well, 10 only has a couple of choices, 1 and 10 and 2 and 5. 2 plus 5 is equal to 7, so plus 2 and plus 5. Well, after you factor, what do you do with each one of those factors? These are two separate numbers that must multiply together to give you 0. So one of these two numbers has to be 0. So let's make that happen. X plus 2 equals 0. X plus 5 equals 0. And when we subtract both sides by 2, we get x equals negative 2. And when we bring this 5 over with subtraction, we're going to get x equals negative 5. Okay, so except for me giving you a point that this polynomial goes through, if it was indeed f of x equals, it is f of x equals. When you find a solution, you're finding a place where the graph, or attempting to find a place where the graph crosses the x-axis. And if it's a real solution, it is where it crosses the x-axis. Well, when you're crossing the x-axis, the y value, f of x, is equal to 0. So this example of how to solve a quadratic with factoring is exactly what we're going to do, but the linear factorization theorem goes in the reverse order. Here's our solutions. Our solutions came from little tiny equations that we had set equal to 0, and those equations that we had set equal to 0 come from the factors that we got from the original polynomial that we factored. Well, check this out. This solution is negative 2, and in here it's x minus negative 2, or x plus 2, right there. So these c values are these solutions. In this case, they're both real solutions of negative 2 and negative 5. And again, the x, if you're looking up here, the x minus c, the x minus negative 5, is x plus 5. Or again, we're just going to work this factorization up backwards. That's what the linear factorization theorem does. All right, enough of that blah, blah, blah. Let's do an actual problem. So we want a polynomial, we want the equation with the solutions of (5 over 2) and negative 4 that goes through, or the function notation of, I'm going to write this like my textbook too, f of 2 equals negative 6. So I'm giving you a couple of solutions, there's only two, Oh, and I have to tell you that n equals 2, so you know the degree of your final answer. Solution, two real solutions, and goes through this point. Now this is function notation, so this is x and y, right? F of x equals -6. So this -6 is the y value. So you might want to see this as +2, +2, -6. Okay, so these are solutions for x. I'm going to multiply both sides here by 2 and get 2x equals 5. And again, still x equals -4. And I'm going to set each one of these equal to 0. I could just say plug 5/2 in for c and -4 in for c and call it a day. But if you do work the factorization process backwards, might make it a little bit simpler because I don't want to work with that fraction like that. So we're going to now have 2x minus 5 equals 0 and x plus 4 equals 0. Well, again, what do you do when you're factoring? You factor, you set each factor equal to 0, and then you solve each one of those little equations. So right now in my work of trying to take the solutions and come up with the polynomial, I'm at this step right here. Now I want to go up the factorization process and say f of x equals a sub n times 2x minus 5 times x plus 4. Don't worry about the a sub n right now. We'll deal with that after we get all this cleaned up. And the a sub n comes into play when we start trying to figure out what point the line actually, well, it's not a line, the parabola actually goes through. So this is going to be f of x equals a sub n. 2x times x is 2x squared. 2x times 4 is 4x, then -5x, except 2 times 4 is 8. -5x and -20. So we're right now looking at f of x equals a sub n times 2x squared plus 3x minus 20. Okay, so we're really close to the final answer, and this might actually be the polynomial that I started off with, but we're not sure about that until we come in and we go, okay, not only did they tell us where the graph crossed the x-axis, well, that'd be if it's real solutions, but not only did they tell us all the solutions, but they also told us a point the line goes through, the graph goes through. It's not a straight line. So let's put this point that the graph goes through into play. Either f of 2 equals -6, or if you want to write that as a coordinate so you see the x and the y, the -6 is the y. Now it's -6 equals a sub n, and I'm going to take the x values out and replace the x they gave us from the point of 2. So 2 times 2 squared plus 3 times 2 minus 20. This comes out to be -6 equals a sub n times 2 squared is 4, and 4 times 2 is 8. 3 times 2 is 6, and -20. And I'm running out of space, so I'm going to bring this up here. -6 equals a sub n. This is 8 and 6 is 14, and 14 minus 20 is, again, -6. Divide both sides by -6 to get a sub n alone, and a sub n comes out to be 1. Awesome. So what that means is now, I don't need to actually change my final answer, because this value of 1 would have to come in here, and as our final answer, right, f of x equals, well, now this is 1, so that's not going to do anything. 2x squared plus 3x minus 20. Woo! I barely fit that in. Bam! All right, so given 2 solutions and a point the graph went through, with the second degree, we knew that was a parabola. Did some work, did our factorization backwards, and bada bing, bada boom, there's our equation. All right, let's do one with some imaginary solutions. Now, as I erase this, where do imaginary solutions come from? How do we get complex numbers? Well, imaginary solutions come from when we attempt to square root a negative number. Now, the quadratic formula we use to solve second degree equations has a square root in it. So just think about that quadratic formula for a second. Negative b plus or minus the square root of b squared minus 4ac over 2a. When you square root a number, you always get two answers when you introduce your own square root. Well, if I'm trying to square root a negative number, that means I get two imaginary solutions, one with plus and one with minus. So complex solutions always show up as conjugate pairs. You're going to have to know that for the next problem. So the next question is, I want an equation with solutions of 4, 2i. The n, or the degree, is going to be 3 in this answer. And it goes through the point of f of negative 1 equals negative 104. Or that point is negative 1, negative 104. I wish I could write really well and look at the camera at the same time. I feel like you're always looking at my back here. So, what do we got? Well, this says it's a third degree, but yet I only have two solutions. The fact that I've included another comma there will hopefully give you a hint. If I have a degree of 3, then any polynomial with a degree of 3 is going to have 3 solutions. Now, not necessarily 3 x-intercepts or 3 real solutions, but it will have 3 solutions if you include all the real solutions, the x-intercepts, and all the imaginary solutions. Well, they gave us a imaginary or complex solution of 2i. But I just said, and with the example of the, or not example, but showing you the quadratic formula, I showed you how they always show up as conjugate pairs. So if they give you one here, the other imaginary solution is negative 2i. Now you might say conjugate. Conjugates are when you take a binomial and you change the middle term. Well, complex solutions or complex values have a real portion plus or minus an imaginary portion. So there is a plus, a 0 in the front of this, like 0 plus 2i or 0 minus 2i. But when you add 0, nothing happens, so we don't need to show it. So this is a conjugate pairing of this complex number. All right, if I keep talking and going off on random tangents to help you understand what's going on, I don't think I'm going to finish. So we've got f of x equals a sub n. I'm going to skip the factoring part because I need some room for this problem, and just say that it's x minus, I'm changing the sign, 4 times x, I'm changing the sign, minus 2i, times x, and I'm changing the sign of plus 2i. And the a sub n comes in again when we're done cleaning up and we're using that point. Multiply the binomials or even trinomials together that have I in there first. You're going to save yourself some steps. So a sub n, x minus 4, x times x is x squared, x times 2i is 2xi, and it's positive. Now it's negative. And now negative 2 times positive 2 is negative 4i squared. Well, what do we have now? We have a sub n, x minus 4, x squared. I got 1 minute left. The 2's are going to cancel out, giving you 0. I squared is negative 1. And that's going to be positive. Distribute this together. And we get a sub n is times x cubed plus 4x minus 4x squared minus 16 equals f of x. And we're almost done, and all you have to do now is plug in this point. The y value is negative 104 equals a sub n times negative 1 cubed plus 4 times negative 1 minus 4 times negative 1 squared minus 16. And when you solve out this arithmetic and you divide both sides by a number to get a sub n, you are going to find out that a sub n is equal to 4.16. And that means our final answer is, sorry about the rush job here at the end, a sub n comes out, 4.16 goes in its place, And bam, I think I'm done. Woo!